Having a presentation from Eva James, VP Global Service Delivery and Global Hubs, Renault Nissan Technology and Business Center India. She'll be speaking on advanced technologies used in Renault Nissan with a special emphasis on industrial AI. Please welcome her on the stage.
A very good morning to everyone. I have to admit that this is probably the first time I'm on stage as the first speaker of the day. So there's a little bit of nervousness that you have to put up with. I typically go in the later part of any of these events, but to come in as a keynote speaker is an honor. And I will try my best to set the context for the day. Before I go into my presentation, the digital revolution in the auto industry with specific focus on the company that I work for, Renault and Nissan. A little bit of a context about who we are. Renault Nissan Tech in India is a 17-year-old GCC working for our two parent organizations, Renault and Nissan. We are one of the largest tech centers outside of the corporate. We are about 12,000 engineers in India, primarily housed in Chennai with satellite offices in Bangalore and in Hyderabad. The 12,000 member team is largely comprised of research and advanced engineering, the core car engineering guys. I lead the technology team. My team is about close to 4,000 engineers who are partners in almost all of the digital transformation initiatives that the firm has taken up in the last few years. And many of the things that I will talk about, we are leading from here. So it's a big matter of pride for us that we are helping our organization, both Renault and Nissan. So, but today, most of the things that I'm talking about is in the context of Renault, all right? So today we stand at the precipice of a very dramatic transformation in the auto industry since Henry Ford's assembly line revolutionized manufacturing about a century ago, right? So the timing is beautiful. The evolution of the auto basic car from being a mechanical marvel to what they call today as a computer on wheels. In fact, I like to say it as a data center on wheels for the amount of data it generates, all backed by technology, AI, and the huge digital ecosystem that comes around a car. Today, we are all living in an environment where autonomous cars are driving in the streets, the EVs are changing the energy landscape, cars are equipped with enough data and intelligence that it can sense when it needs maintenance even before you realize that. Factories are becoming intelligent, they're making very conscious decisions on how to organize and operate. All of this is changing the way we drive, the way we move. It's reimagining mobility and completely giving a phase shift to all of this. So today in my 15-20 minutes that I've been allotted, I will talk about a few things that we are doing in Renault in the digital transformation space. The first is the digital twin, right? I want you to imagine designing, testing, perfecting a car without actually building a physical component. Right? Typically, when you think of a car, you think of it as like a Lego, right? A lot of parts coming together and you build a car. But imagine doing all of this and making sure that the car that you're going to build is going to be absolutely the car that you want before actually looking at any physical component, right? And that is where the concept of digital twin comes into picture, right? In very simple words, digital twin is nothing but a digital replica of an object, of a part, of a space, or a process, right? And in our context, a digital twin is a virtual replica or a digital replica of a car. That's our primary product, right? But that's not the beauty. The novelty is not having a digital replica. The novelty or the beauty of the digital replica or the digital twin comes into place even before the physical car comes into existence, right? And that's the beauty, because today, our engineers in the virtual space are able to design, engineer, test, do everything before the car can actually be produced, right? And what does this mean? This means that they are able to test the perceived quality, they are able to test the ergonomics. In fact, very recently we had a breakthrough where using the virtual replica, the digital twin, the surface reflection testing was able to 100% be completed for certain car models, which was, I'm told, was the first in its kind with photorealistic accuracy, right? Not only that, our engineers are able to place virtual travelers inside a digital twin to generate crash testing simulation, ergonomics, human machine interface testing, air conditioning efficiency. So everything that in a traditional world was done after the first prototype was built in the plant is now being done in the digital twin, right? What does this mean to us? This means that we are able to preempt a lot of design challenges, challenges that typically come during the testing phase well ahead of the game, right? Which means our cars can be produced with higher quality and in a much better timeline. In an industry where time to market can make or break car sales, this is a game-changing thing. This wasn't easy, right? This wasn't easy because when we started in this journey about a few years back, the knowledge on how to do this was new to the team in India, right? So how did we upskill our people on technologies around? We are a big partner with Dassault Systems, and traditional PLM software is what we have been using. So how do people pick up skills on Team Center, 3D experience? How do we tie these things together? How do we tie the virtual twin to the BOM, to the downstream applications? So this was a big learning curve, but I would say that the India team, we called it the Renault Virtual Twin. The program was called RVT. But we were, about 85% of the RVT program was done out of India, right? Of course, the first cars for which this twin was built were for the cars in Europe. So we had a lot of product planning and others in France and in other European countries. Because the regulators were still there, the homologation had to happen in France. But the entire technology backbone for this program was done out of India. Did we stop this transformation with the car? Right? That was the next thing. Sorry. And how do I go back? You. Okay. So did we stop the digital transformation with the car? No, we did not, right? We went beyond the car and we said, how can we look at using the same concept to our manufacturing plants? And that was the birth of the industrial metaverse. Again, very proud to say that Renault was one of the first auto organizations in Europe to go for large-scale industrial metaverse programs, right? And this program, again, majority of the work was done out of India. And what does this mean? I mean, picture a scenario where every single component, every single equipment, an assembly line, persona inside a plant, be it a body shop worker or a supervisor, has a digital avatar, right? And these digital avatars are able to talk to each other, not inside the plant, but in a digital platform, which can be monitored and viewed from far away from the actual plant premises to take meaningful insights, to make run decisions at real time, right? Imagine these are real life use cases. Today we have body shop workers who are learning to paint the few parts of the car without actually touching an iota of paint, right? We have 15,000 plus components that are generating close to about 3 billion data points on a daily basis. We have, again, as most of you know, an auto industry thrives on a partner ecosystem, right? There are thousands of parts which come into play. When parts come into play, we are heavily dependent on logistics, inbound and outbound. Cars go out to the warehouse, yards, to all these places. So this industrial metaverse is not just an inward-looking program, but this encompasses the entire ecosystem that comes together to build a car, right? And the beauty of this program, again, was this was conceptualized within the group and built by the group, right? So this was not like a third party that came in to do it. And when you look at the technologies which came together to build it, right, we had to make sure our entire plant we have about 14 plants in Europe alone, have to be connected. Every inch and every centimeter of the plant would have a network which connects equipments, which connects the systems that are running it, the movable robots inside a plant, all of them are connected. The second is we have enough simulations to monitor these movements, their behaviors, their downtime, what is going well, what is not going well, what equipments are needing maintenance. Once we had to train these models, today most of these equipments are in a self-maintenance mode. And of course, I spoke about the ecosystem integration. And the large is the application of very interesting big data platforms, which many of our supervisors sitting at their desks far away from the plants. In fact, many of these plants are remotely monitored from India by my own team, because the amount of sensors and the data that it generates is humongous, right? And all of this comes to us. How has this impacted our plants, right? As I said, the way we are able to train the workforce in the plant, the way our assembly line equipments are able to run with good maintenance, the stocks that we need to have the assembly lines running at the optimal level, the stock maintenance is improved significantly. Our energy consumption is monitored and kept at an optimal level. Our logistics has improved significantly. At the end of all of this, both between the digital twin for the car program and the digital twin for the plant, we had a very ambitious program called LEAP 100. It was lean, efficient, accelerated planning. Today, most of you know that China is killing the auto industry by bringing a car into the market in 18 to 24 months, right? A traditional OEM in the past was taking about 3 years to get a car from concept to the street, right? So we launched a very ambitious program called LEAP 100, whereby we wanted to crunch the vehicle development timelines to 100 weeks, which is about 2 years. So through our interventions, the digital twin program of the car, the RVT, and our industrial metaverse program, we've been able to very successfully come close to the 100 weeks. We are not there as yet. We are still coming closer. But this program has been made a reality through these two programs, the digital twin program and our industrial metaverse program. Again, both the programs had a very bumpy ride. It was not easy, both from a technology adoption, change management. A car industry, an auto industry cannot survive and thrive without our partner ecosystem. So how do we bring all of them up to a certain speed and agility that together the industrial metaverse program can be successful? So the last few years have been significantly challenging, but today, as I said, the LEAP 100 program is very close to being termed as a successful program. We will be at 100 weeks by the end of this year, right? And that would be thanks to these two initiatives of us. So I have a small video that I would like to play, which talks about our industrial metaverse program.
The story begins around 2017. Here we are in Renault Group factory. The production line you see before you is made up of various people and parts. Let's call them objects. Each object, screwdriver, robot, truck, or even packaging material, generates data. Each object has its own interface, its own language, in order to share that data, a language spoken by no one else. Each object has its own name, but that name also changes according to each interface. And so Screwdriver 17 becomes Machine 808 or Atlas Copco 2840. A true industrial Tower of Babel. Renault Group is the first to become aware of the issue at play. There needs to be a platform that brings all objects together using a single set of standards so they can seamlessly interact with one another. Step 1. Install the telecommunications infrastructure they need to communicate. From 2017 to 2019, 6,000 acres of workshops are equipped with the necessary networks. Each object is modeled, ID'd, connected, and given a digital avatar. All the ingredients are now ready for the birth of Renault Group's industrial metaverse, a true-to-life digital replica of the group's factories and entire supply chain. It provides a real-time simulation of the entire ecosystem and the countless relationships between avatars, making it easier to optimize the way they function in the physical world. What are the benefits? There are plenty. Our environment is becoming more and more complex by the day. The Renault Group Metaverse makes it easier to see, assess, understand, and therefore act in a timely manner. Reduced costs and increased quality. Real-time systems means you can intervene in the right place at the right time. Real-time monitoring and traceability of key parameters means enhanced prevention and early planning. Our environment is also prone to unforeseen events. Accidents, disasters, real-time simulation makes it easier to quickly adapt to such events when they arise. The Metaverse helps us become more agile and resilient. Constant precise analysis of avatars means better stock management when you know exactly what you have and where it is. You don't need backups. That's a proven savings of 20 to 30%. Our customers will be delighted, especially given the reduced turnaround times, with considerable reductions in the time it takes between placing an order and receiving a delivery. Another essential factor for Renault Group is how this benefits society. The carbon footprint is at the heart of our concerns. Real-time analysis of our energy consumption with live simulation on the Metaverse helps us further optimize our energy use. Not forgetting the people involved. While the tech involved is quite exciting, the Metaverse broadens one's horizons. Because employees are given a much broader vision of their role within the group, they are more likely to take initiatives and make the right decisions. This is the full meaning behind our slogan, digital tools serving people. Standardize, synchronize, optimize. Above all, the Renault Group Industrial Metaverse places us at the cutting edge of a new era.
While it looks fascinating, it wasn't easy because many of the systems that are running behind the scenes were probably built when I was still in school, right? To get to a legacy system, talk to these kind of modern infrastructure was never easy. Of course, change management was a big issue, and more important was the cyber security, right? No one connected cyber security and cars 15 years back. But with connected cars, connected factories, digital twins, cybersecurity became of paramount importance to us, which required dedicated focus. So amidst all of this, these programs came alive. It is not just digital twins that are changing the face of the auto industry. There are a few others that I just want to broadly touch upon. Today we are talking of driver ADAS programs, which helps drivers with basic things like automated braking, lane assistance, parking assistance. How do you navigate in a congested street? How do we help autonomous vehicles to avoid obstacles, adhere to traffic guidelines? So AI is pretty much touching every length and breadth of the auto industry, right? A very important element is how it touches customer experience. Right? During the COVID period, right, a few years back, when people were not buying as much cars, but even when the ones who wanted to buy, how do we give them a virtual experience, right? The whole concept of virtual showrooms was conceived when built, and that would have been possible only because we had these kind of technologies, computer vision and all of these stuff, right? We are talking about manufacturing optimization that we just saw, supply chain optimization. So across all the dimensions of an OEM life cycle, today we are able to bring in technology. In fact, today, one of the largest teams that we have is an SDV team, the software-driven vehicle, the connected services both inside and outside of the car. So in a nutshell, I would just like to wrap up saying that it's a great time to be in this auto industry. I've been with this organization for 10 years. I used to work with the BFSI segment before, and I was charmed by how technology is changing the fintech world. But when I came here, and I just got mesmerized, but how technology is shaping the auto industry today, and I'm glad that I'm here, because the future is going to be even more exciting with the cars changing the face of mobility. It's not about going from point A to point B, right? The car is almost becoming an extension of your homes. The connected services are changing it, and all of that, the enabler for everything is technology, and I'm glad we are doing this from India for the corporate. So again, thank you for the opportunity. I just wanted to share these insights about what we do in India for the global organization. Thank you.
It's a great presentation.